Okay, dear all, today we're going to cover the chapter 17, temperature and heat. So this is the first chapter. We're going to talk about heat. So this chapter is not very difficult. Most of the concepts mentioned in this chapter are kind of common concepts in daily life, so it's relatively easy. So now let's go through the chapter 17, temperature and heat. So here's a preview of the chapter. In this chapter, we're going to learn several most important topics. So the first one is the meaning of thermal equilibrium and how does thermometers work. So next we will learn the physics behind several temperature scales, including absolute or Kelvin temperature scale. And then we will learn how the dimensions of object changes as a result of temperature change. As we all know, when temperature is higher, most of the objects are getting bigger, which is expanded due to the temperature increase. We will learn what is that and why is that. And then next topic, we're going to learn how to calculate heat flow, temperature change, and change of phase. Here, the change of phase means the change of objects from one phase to another phase. By mean phase, we mean three different types of phases in this physics lectures. For example, one object could be in solid phase or liquid phase or gas phase. And for example, for waters, it could be solid phase, which is ice, and liquid phase, which is the liquid water. And if the temperature is high enough, the liquid water could become gas phase. We'll learn how the object changes from phase to phase. And then heat. We'll learn how heat can be transferred by different ways. So there are mainly three different ways of okay, let me change the pointer in the pen. That might be more helpful. So we'll learn how heat is transferred. There are three ways. The first way and most common way is conduction. The second way is convection, and the third way is radiation. Okay, that's all we are going to learn in this chapter. Okay, so here is a short introduction for heat here. So iron melt at 1500 degrees, and we see the picture. This is a molten iron. So does this high temperature molten iron contain heat? Okay, let's do not answer this question now. So after the chapter, you will get more clear idea of the definition of heat. And in this lecture, we talk about heat and temperature. So the terms temperature and heat have very different meanings, even though most people use them interchangeably. But in physics or in science, they mean different things. We will learn it later. In this chapter, we'll focus on large-scale or macroscopic objects. And in next chapter, we're going to take a look at the microscopic scale of the similar topics. Okay, so first of all, what is temperature? and what is thermal equilibrium? Usually we use a thermometer, which is shown here. This is a very classic thermometer to measure the temperature. And how does this thermometer work? We're using some features of the liquid in the thermometer because the volume of the liquid in the thermometer changes with temperature. So usually in a thermometer, we have some liquid. Usually it's mercury. Sometimes it might be some other liquid, but most of the time it's mercury. Like other liquid, mercury's volume is getting bigger when the temperature is higher. So if you see, if you put the thermometer in a high temperature environment, then the volume of the liquid is growing bigger. Then you will see it's growing, and you will see the bar or the scale is getting higher and higher. And this is how thermometer work. That's the mechanism behind the thermometer. So this is the function or mechanism of the thermometer. And another thing is equilibrium, thermal equilibrium. So we call two objects or two systems are in thermal equilibrium if and only if they have the same temperature. If they don't have the same temperature, then they are not in they're not in the thermal equilibrium. For example, if we have two objects, A and B, so now A is 10 degree, B is in 20 degree in Celsius degrees. So this is A and B. So now we have a question. Are A and B in thermal equilibrium? Please think about it. And the answer is no. So after some time, A and B, they may have the same temperature. Maybe it's 15 degree, and this is 15 degree too. Because when they get in contact, the heat will be transferred from B to A because B has high temperature and A has low temperature. And finally, they will have the same temperature. For example, maybe they will have the same temperature as 15 degrees. Then this is in thermal equilibrium. Okay, so this is the definition of thermal equilibrium. It's not a difficult concept, it's very easy. So there are some other types of thermometers. For example, a temporal artery thermometer measures the infrared radiation from the skin. It uses some different mechanism of compared to the previous classic thermometer. Okay, so although the thermometer cover touches the skin, the infrared detector inside the cover does not. For example, this is the thermometer you're using. Actually, the sensor of the infrared detector might be here. So the sensor doesn't contact with your skin, but there's some radiations from your skin to the air and to the sensor. So the sensor will sense the infrared radiation from your skin. If your skin has a high temperature, the radiation is stronger. If you have a lower temperature, the radiation is lower. So the sensor will sense the radiation and make a measurement of how strong is your radiation, and then how high is your temperature. This is a region or the mechanism of such kind of thermometer. And of course, besides this type of thermometer and the previous classic type of thermometer, there are a lot of other different thermometers. And here we just show two examples. Okay, now let's learn some physics of the thermodynamics. The first thing is the zeroth law of thermodynamics. And in the future classes, we're going to learn the first law, second law, and in the thermodynamics. Now let's see the zeroth law of thermodynamics. It states that if C is initially in thermal equilibrium with A and B, then A and B are in thermal equilibrium with each other. So this is easily understandable because let's see this picture. If C is in thermal equilibrium with A and C is in thermal equilibrium with B, even A and B, they are isolated, still we can get a conclusion that A and B, they should have thermal equilibrium. Because, do you remember? Thermal equilibrium means they have the same temperature. Now, if the temperature of C equals to the temperature of A, meanwhile, temperature of C equals to temperature of B, then of course temperature of A equals to the temperature of B. That means A and B, they're in thermal equilibrium. This is very easy understandable, right? Okay, that's very easy, and that's the zeroth law of thermodynamics.